It is section 8.4, trigonometric substitutions. In some cases, the U substitution can be in the form of a trigonometric equation. It is particularly true when you are dealing with square roots. Here, let's see expressions. Square root of a squared plus x squared, a squared minus x squared, and x squared minus a squared. For these expressions, the typical substitutions are given in this way. Now, I'll explain geometrically how these are made. Okay. Now, for this radical, x can be any number, so that it can be very small, negatively, and around zero, and also can be very large, so that x can be replaced by tangent theta with a scaling, so that inside the radical, it can become now a squared is common, and that will be 1 plus now tangent to square root theta, right? So that now it can go out, and here 1 plus tangent square theta is sec squared theta, so that you can eliminate the radical. The reason is that x can be any number in real line. There is no restriction. So that if you choose, now x is 8 times tangent theta, then now here, if theta moves from minus pi over 2 to pi over 2, then if a is positive, then it is increasing function, so that now covers whole value, all values. Now, for second one, look at that one. Here, a squared minus x squared inside the radical cannot be negative. So here, a squared, x squared cannot be larger than a squared. So the sine function has a value between minus 1 to 1, so that if we are using a sine theta for x, then this one is always bounded. And then, now along with that, the substitution, the inside radical will become a squared is common, and 1 minus sine squared of theta, which is cosine squared of theta, and we can eliminate radical. And of course, over there, for invertibility, now we are choosing theta minus pi over 2 to pi over 2, where here sine theta is increasing and one-to-one function. Now look at that one. For that one, x squared must be always larger than or equal to a squared. So that, for example, if we are using sec theta, then a squared sec theta, so that a squared is common, and sec squared theta minus 1, which is tangent to squared theta, so that here we can eliminate radical. Now, that one also must be 1-to-1. Of course, tangent theta is 1-to-1 over here, and then sine theta is 1-to-1, and then sec theta it must be 1-to-1. Now, sec theta is 1 over cosine theta. Cosine is 1-to-1 between 0 to pi. Now, its reciprocal as in the shape, it's given in this way. Now, is x-axis. Now, between 0 and, okay, here, center is pi over 2. Just a moment. It's a vertical line is somehow made. The software is not stable. Okay, pi over 2. And now 1 over cosine theta will blow up in this way, and here, and then again here now it's blowing up in bottom direction. Okay, just a moment. So it's if I take a long, then he automatically make a straight line. Okay. So in this way, now sec theta can be made at pi over 2. The value doesn't exist. But anyway, this half is blowing up larger than 1. Okay, this height is 1. Now that below height is minus 1. So the sec squared theta is always larger than or equal to 1. So if we are using x, and here a sec theta, then a squared sec squared theta must be larger than or equal to a squared. So inside radical is now non-negative. Okay, let's look at one more time. Tangent theta, and we are using tangent theta, sine theta, and 1 over cosine. Now, this one is used for all possible values. This one is used for between minus 1 to 1. Now, this one is used for now here larger than 1 and smaller than minus 1. So their usages are different, right? So you can understand it that way. The main thing is that you cannot make a negative inside radical. Now for the substitution, the reference triangle can be given in this way. Now tangent theta is x over a, so here x over a. Now for second one, sine theta is now x over a, so that here that is x over a, sine theta, and then sec theta is now x over a, so the sec theta is now that direction x over a, right? So by using Pythagorean theorem, the last one can be decided. Okay. Now, when you here eliminate radical, don't forget to putting absolute sign. But for definite integral, sometimes the region is given so that you know what it is. But eventually, this whole thing must be non-negative, so that in the region, some region without absolute sign, if it is negative, then you have to put negative so that it must be positive. Okay. Okay. Now with the substitution, okay, we can see that way, and then later on, we are trying to use the is inversion. So here in this substitution, now tangent theta, sine theta, sec theta are all one-to-one, so that inversion must be possible. Okay. Okay, let's go to problem here. Now we focus on inside radical. Then now x squared must be always larger than 49. So that means that we have to start with x is 7 sec theta. In this case, here theta must be between 0 and pi over 2. Now, as you can see from this picture and that one, so that and larger than that, okay. And because we here consider x is larger than or equal to 7, there on, because of that condition, here we have only theta becomes between 0 and pi over 2, okay? Okay, along with that, now inside radical, that is the same as now square root of 49, and now that is sec squared theta minus 1, right? And that is tangent squared. theta, so that is 7. And between this angle, tangent theta is positive, so that you don't have to put absolute sign. Okay. On bottom, now that's a 7 sec theta. So the given integral can be changed here. The top is 7 tangent theta, and bottom is now 7 sec theta, 7 sec theta, and d theta. Okay. Now I forgot here. Dx must be computed. Okay. Dx must be 7 sec theta and tangent theta and d theta. Okay. So here that must be before d theta, you have to put 7 sec theta and tangent theta and d theta. That sec eliminated and cancel out, so that we have here, that is twice of now here tangent and square theta, d theta. Right? Okay. Now for that one, here, if we try to use the identity, that is sec squared minus 1, then here now, oops, that must be 7, right? Okay. So there's 7 integral sec squared theta minus 1, and here the theta. Okay. So that is now derivative of tangent theta. So the 7, okay, that is tangent theta, and minus here theta. Okay. And plus c. Now, what is tangent theta? Here, sec theta is here x over 7. So if you draw the reference triangle, then now if this is a theta, then here there's always a larger than equal to 1, and so that this x is a larger, so that's 7. X. That is x, and now there is a 7. Here, sec theta is x over 7, right? Okay, so that one is the same as now square root of x squared minus 49. So tangent theta must be here, so that's 7, and tangent theta must be square root of x squared minus 49 over 7, right? Okay, somehow line is made. Okay, now we have to put here theta. Theta is just simply x over 7 now sec inverse. Sec inverse and x over 7. Okay, so that is plus c. That's the final answer. Okay. That is now, okay, here x over 7, there is a sec inverse, so I forgot here putting inverse. Okay. Now for this one, here y squared cannot be larger than 25, so that the choice is now y equal sine theta. Then, okay, square root of 25 minus y squared is the same as square root of 25 and 1 minus sine squared, which is cosine squared. So that is the same as now 5, and here 5n cosine. Okay, now we have to put absolute value of cosine here now. However, now angle theta is between minus pi over 2 pi over, and over there cosine is always non-negative, so that you can reach it here 5 cosine theta. Okay. Now, what is dy? dy equal 5 cosine theta d theta. So that the given integral is now, this portion is same as 5 times cosine theta, and dy is again one more 5, so that now that is here 25 can go out, and cosine square theta d theta, right? That is the same as here half 1 plus cosine 2 theta. So that is now 25 over 2 integral here 1 plus cosine 2 theta d theta. Okay, that is now 25 over 2, and that is a theta plus half sine 2 theta, and now plus c. Okay, now we have to replace theta by using now y values here now. Okay, theta itself is same as arcsine and y over 5, so it's okay. But now for that one is you have to be a little careful. Now, because we don't know the 2 theta, and by using again trigonometric identity, we can reach at 25 over 2. Okay, that one, let's write down this one. Okay, now there's arcsine and y over 5, and that one is the same as, now this part is twice of sine theta cosine theta, so that along with a half, so that is now cosine theta and sine theta plus c, right? Now sine theta itself is y over 5. Now we have to evaluate cosine theta. Okay, let's draw the reference triangle. Okay, for that one, here we choose this as a theta. That is now theta. And then now sine theta is y over 5. So that is now y, and okay, 5 and this y, right? Okay, now the bottom must be here 25 minus y squared, square root of 25 minus y squared. So that cosine theta, from here, cosine theta must be here square root of 25 minus y squared over 5, right? So now for this one, here, this term, and then this portion will be changed to, into square root of 25 minus y squared divided by 5, and sine theta is now y over 5. So that instead of this, you are putting this, and then that will be the final answer. Okay. Now here we have note for trigonometric substitutions. You may first consider the fact that the radicand must be non-negative. Right? So earlier we considered that when you are trying to use the substitution, then for that one, x can be any number. So we choose tangent. Now for that one, x must be limited between -1 to 1, in fact minus a to a. So we are using sine theta. Now x must be larger than a and smaller than minus a, so that we have to choose secant theta, right? Okay, now we'll go a few more problems. Okay, for this one, x can be any number, so that we can choose here now x is now 2 tangent to theta. Of course, theta must be between minus pi over 2 to pi over 2, right? Okay, so here, now along with that, square root of, okay, along with this one here, square root of now x squared plus 4 must be now 4 tangent to square theta plus 4, so that is square root of 4 and tangent square theta plus 1, right? So that is sec squared theta, so it is the same as 2 sec theta, right? Okay, now and here x cubed is just simply 8 times tangent cubed theta, and then now here, okay, now dx, okay, that is same as here 2 sec squared theta and d theta. So we combine them. So the given integral is the same as, okay, on the bottom, that is 2 okay, sec theta. Okay, that is sec theta and absolute sign. And then top must be here power 3 over that. So the 8 times here tangent and cubed theta, right? And then we have dx, that is same as 2, and here sec squared theta and d theta. Okay, now we can cancel one of them here from here to there. Then 2 canceled and 8 can go out, so that 8 times integral. Now that is tangent and cubed theta, and here that is a sec theta absolute value, right? So here sec theta can be positive or negative, so that and you can choose 2 cases. However, anyway, for simplicity, we may ignore this absolute sign. Now, when you are, so that we may assume this is positive. Once it's negative, then you have to put negation in front of that. Okay. Now, for this kind of problem, and we may try to use a U substitution and for tangent theta, or U substitution with sec theta. Now, if you try to do substitution with tangent theta, then you have to put aside the sec squared. But only we have 1 sec, so impossible. Now, if we try to get sec squared substitution, sec substitution, then we have to put aside and tangent and sec. Okay, so that portion with ignoring absolute sign can be written here. Now, tangent squared theta and tangent theta and sec theta. Okay, so that is now along with d theta. This part must be here. If u is now sec theta, then that is du, right? Okay, now for that one, we can change this one into sec squared theta minus 1, right? 1 and this portion here, okay? So by using now u, okay, by using u is, okay, that is sec theta, then du must be here, okay, sec theta tangent theta d theta, right? So the given integral is the same as now 8 times, okay, for this portion that is u squared minus 1, right? And then for the remainder part, they're the same as du. So that is the same as 8 times and 1/3 u cubed minus u and plus c, which is same as 8 times of 1/3. U is now sec theta, and okay, that is cubed, and minus now sec, okay, sec theta. Okay, so we reach this one. Now we have to evaluate sec theta, which is 1 over cosine. Now the reference angle, we'll make a reference angle here, and okay, stop here, and then we are making vertical line, and now, okay, I don't know the property of the software, and it's a little bit unstable, but anyway, we'll see it here now. Okay, now that is theta, and here tangent theta is x over 2, so that is x and over 2, right? That is tangent theta, and the hypotenuse must be x squared plus 4, right? Now for that one, and sec theta is that ratio. So here sec theta equal same as square root of x squared plus 4 divided by 2. So over there, now that divided by 2, okay, so over there, now sec theta is replaced by this term, then that's the final answer, okay? Now for that one, now again, this is x cannot be larger than 1. Here, that is now in half power square root and whole thing squared, so that square root of that here must be well defined by here becoming non-negative, which means x cannot be larger than 1, so that we choose here x is now cosine, okay, no, sine theta. Okay, sine theta, okay. Then now dx must be cosine, oops, okay, I'm sorry, I'm not familiar with this new software, so that cosine theta d theta. Okay, here x is 0, means that from here theta is 0. Now x is and square root of 3 over 2, and then now theta must be here x is square root 3 over 2. That is happening, okay, right now pi over 3, okay, sine that one, so that here 2 and square root of 3, okay, so that is a pi over 6. Theta is pi over 3. Okay, pi over 3. Okay. So here, the given problem is changed into now from 0 to pi over 3, right? That is pi over 3. Okay. Now, pi over 3, and top is sine squared, and then bottom is now, okay, 1 minus sine squared, which is same as now cosine squared, so that is now cosine and third power of theta, and then there is cosine theta d theta, which is dx, right? Now, we didn't use absolute sign over there between 0 and pi over 3, that is positive. Okay, now along with that is same as now from 0 to pi over 3, and that is now tangent and cancel 1, and sine squared over cosine squared is the same as tangent squared theta d theta. That is now sec squared minus 1, so that sec squared antiderivative tangent theta, and minus 1, that is theta, and we evaluate here pi over 3 and 0. Okay, so once 0 then is 0, and pi over 3, then now here tangent must be square root of 3, and then that is same as pi over 3. So square root of 3 minus pi over 3 is the final answer. Okay. Now here we summarize the procedure for trigonometric substitution. Okay, write down the substitution for x and calculate the differential dx and specify selected values of theta, the angle, and substitute the trigonometric expression, and now here use the calculate the differential, and then simplify the result algebraically. Now after integration, keep in mind that the here we have to restrict the angle for reversibility. Always a substitution must be made one-to-one manner. If it is not reversible, then substitution is wrong. And at the last moment, try to draw an appropriate reference triangle to reverse the substitution. Okay. Now let's try to solve here the problem. Okay, for that one, now x can be any number, so that here we start with okay, x is now 2, x is 2 tangent theta, and then now here inside radical, there's a 4 plus 4 here inside radical is a 4 plus now 4 tangent square theta, so that will become here 4, and 1 plus tangent square theta is sec square theta, right? Okay, now for that one, here we can have twice of sec theta absolute value. Okay. Now what is dx? That is same as 2 sec square theta, and here d theta. So that the given integral is the same as now here 2 cancel out an integral, and top is sec squared, bottom is sec theta, so that eventually there is absolute value of sec of theta, d theta. So once it is positive, then here you can get that, and so that anyway you can reach at this one. Okay. So here now, in fact, it cannot be negative, and for that one, so that anyway, once you get that, then once it's negative, then you have to put here negative sign, so that anyway you have to reach that over there, so that the answer must be, now it can be positive or negative, and logarithm, and the antiderivative of this one is this one, so that sec theta plus now tangent to theta plus c. Now you have to replace sec theta and tangent theta. Tangent theta is directly x over 2. Now for sec theta, we have to use the reference triangle here. And if this is a theta, then now that substitution means that that is now 2 and this is x, right? Okay, so here the hypotenuse is now x squared plus 4. The sec theta is the ratio over there. So that now from this one, sec theta is the same as here square root of, okay, square root of x squared plus 4 over 2. Depending on the region, it can be here, it must be positive and negative, so that we can say that way, okay? Okay, but anyway, that can be positive or negative, anyway. And tangent theta is x over 2. Okay, now for that one, here, now this term, whole thing, must be larger than or equal to 2. That means that here, 25, okay, so that now if we are choosing x equal, now let's say in this way, 2 over 5 and sec theta, then it's larger than or equal to 1. Now square will make it 25 and top will make it 4. So the cancel with 25 and 4. Okay, so that inside radical is always non-negative. Okay, that is substitution. Then from here, now dx must be same as 2 over 5, and now sec theta and tangent to theta and d theta, right? Okay, here, now inside of radical, that is now, okay, square root, that is same as 25 times that squared will be now 4 sec squared theta minus 4. So that must be same as twice of sec squared minus 1 is tangent squared theta. So that tangent theta absolute value. And here x is larger than 2 over 5. That means that here sec theta is larger than 0, and the area tangent theta, okay, larger than 0, and sec is given from here, and that is pi and in the half, and sec is coming this way, and sec is coming down that way. So here now x is here now, okay, and that one is larger means that sec theta is larger than here, so that the angle must be between here to there. Now, over there, tangent theta is positive, so that there is 2 tangent to theta. Okay? Okay, now along with that, the given integral is integral. The bottom is, okay. Somehow the subject is too sensitive. Now bottom is here 2 tangent to theta. And the top, dx is now, okay, 2 over 4, 2 over 5. Okay, 2 over 5 and sec theta and tangent theta and d theta. So we can cancel here. Now 1 over 5 can go out, and then integral sec theta d theta. Okay, by using the hint here, we can get the result is same as now here 1 over 5 and logarithm, and that is sec theta plus tangent theta plus c. Now again, for sec theta, we can get easily 5x over 2. Now for tangent theta, you have to make that part as a function of x. Now again, you can use reference triangle. The reference triangle is made in this way. Now, if this is theta, then now sec theta is ratio between this one and that one. So that here, now this is a larger one. So that x and 2 over 5, right? You can multiply 5 over there, but anyway, okay, let's try to multiply 5 so that, okay, so rather than this one, we may put this one, and that is a 5x, okay? So 5x is 2 cosine theta, so that 2 must be this one, and that must be 5x, right? Then, from Pythagorean theorem, that length must be now square root of the squared 25 x squared now minus 4, right? And here tangent theta is ratio between this one and that one. So this one over that one. So that's exactly this one. Okay. Okay. That's the end of the section. Thank you.